Welcome everybody to our webinar. It's about successful applications of AI for business, and the most interesting part, of course, the real cases. And who we are Avenga. We are digital transformation champions who are present on 3 continents, in the United States, in Europe, and in Asia. We have 19 offices, 2,500 plus specialists, 350 clients and counting, and more than 20 years of experience. So we are definitely confident that we know what we are talking about. And who we are today as the speakers is from right to left. Olena Domanska, Head of Data Science at Avenga, Lyubomyr Senyuk, R&D Director at Avenga, and me, Jacek Chmiel, Director of Avenga Labs. And we encourage you to use our Zoom chat to share your thoughts, to ask questions. We'll try to address them during our Q&A sessions. We're going to have one Q&A session after each of the topics, so there will be 2 Q&A sessions today. Let me briefly introduce you to the topic. AI in itself is quite old. It started in the 1950s, and there was a long period of AI hype that ended up, unfortunately, of a huge disappointment in 1980s that it's called AI winter, that most of the projects were frozen and humanity lost hope in AI. But since around 2012, the hope is back again with us, and we found many practical implementations and applications of AI technologies, in particular machine learning, for the business purposes. That's what we are talking about today. There are many useful applications, and today we are focused on fraud detection and natural language processing. These are the topics of today. Fraud detection. We have so many types of fraud, including identity theft, credit card fraud, insurance fraud, loyalty program fraud, misuse of company resources, accounting fraud, and even recently election frauds, and many more. And the number is growing. And what is even worse is that these frauds are becoming more and more sophisticated, more and more automated, including, ironically, using AI technologies to develop new ways to perform fraudulent activities. Let's talk about our case.
Yep, I will probably introduce the first case. So the company who was our client started as a personal inventory startup based on San Francisco. So what they provided to users, they proposed them to just list personal belongings with some additional attributes like price, like attached documents regarding like checks, like some warranty documents, probably some support documents and other stuff. What this give to user? Actually, user was able to see the whole list of belongings, the value, like in money. I mean, what he or she possess, and was able to see, for example, actually to manage the personal inventory. And you will ask how fraud detection actually is related to this. It's interesting question. It's hard to imagine what kind of user should try to do some fraud to this business, but this business finally transformed to a micro-insurance company. And Olena will tell you now some details what exactly they were doing in terms of fraud detection and how they helped to this company to protect themselves.
Thank you, Lyubomyr. Yes, so I was personally involved into that project, so I would be happy to provide some details about it. But first of all, I would like to mention that this company had an innovative on-demand approach to insurance, meaning that no long-term coverages were required. That is, customers were allowed to protect anything they wanted for any time they wanted, and it could be literally 30 minutes during their commute from home to work. And what was even more interesting, that they were allowed to start protection entirely from their phones or websites, and just with several clicks. So having such flexibility with their offerings, the client's business model was heavily affected by fraud. Even though the agents spent literally days to weeks assessing each separate claim, the accuracy of fraud detection was not sufficient. So the client wanted to save money. The client wanted to make the process scalable, to prevent fraud-related losses, and actually decrease the time for claim resolution, and ultimately increase the satisfaction level of the customers. So the client came with a problem. How did we tackle this problem? What we did, our data science team developed a robust fraud detection system. But we started with the very beginning, and as the first step before the labeled training data set was gathered, was collected, we started with an unsupervised clustering approach to identify the potential suspicious claimants. So what is important here is that we paid a lot of attention to feature engineering. So we leveraged our knowledge in domain in order to create features. Please go to the next slide, and we will see. So we paid a lot of attention to this feature engineering part, and we came up with features related to behavior analysis of customer on the website, related to payment, related to some communication between agents and clients and customers. And we can see it on the next slide as well. Yeah, so during the later development phases, when we have collected at least some labeled fraudulent claims, we were able to apply a semi-supervised approach. The final model was a combination of rule-based approach and this semi-supervised approach based on variational autoencoders. So the approach condenses the data and basically learns this compressed representation, and ultimately can predict whether the claimant is typical for the system or fraudulent. So on the next slide, we will show how the system works. So once the customer submits a claim, this system generates features first of all, and then predict the score of that particular claim, being fraudulent or typical. And actually, the model gives this risk score, and it could be set as a threshold for accepting, denying, or manual review of the claim. So on the next slide, we will see the results of this. It turned out that this developed solution turned out to be super fast at inference time. It was scalable, it was efficient, and it was accurate. So it helped our client to lose the lower ratio, to accelerate payments on genuine claims, and to optimize cost.
Yeah, so as we discussed before, this wasn't an easy project. So what were the most difficult elements of the projects that we had to tackle?
Yeah, so I can probably start with what I already mentioned, that we started a cooperation with this client from the very beginning, since it was a startup. So the company didn't have a lot of customers back then, let alone fraudsters itself. So, on the other hand, most machine learning algorithms take a lot of data in order to work properly. And you probably all heard about the famous paper, The Unreasonable Effectiveness of Data by Peter Norvig, who is current Google's research director. So he showed that for complex solutions, the data matters more than algorithms. And we dealt with small data set. So the challenges included the lack of training data, the bad quality of data. So we had a lot of missing data in customers' profile, and our data set was imbalanced. We had much more typical customers and claimants compared to fraudulent.
Yeah, and actually the third problem, important not only in this case, but generally in neural networks and modern AI, is models explainability. What does it mean? Actually, especially in this business, imagine you are blocking some user from doing some transaction. User can lose his or her money and other stuff. So you will meet this user from legal point of view, and you will be forced to actually explain why you blocked this transaction, because user was trying to ensure some important stuff for him, and you just blocked without explaining why and so on. So in this case, modern neural network architectures actually are not providing good ability to explain why model decided to do the certain action. But still, in data science, as Olena mentioned, we used some different techniques that actually allow to provide some explainability. For example, you can use decision tree and similar techniques.
Okay, so let's talk about the future of AI-driven fraud detection. And we already discussed before, so let's start with Olena. What's her opinion on this?
So, in my opinion, the most promising modeling paradigm for studying such a complex adaptive system is simulation technique, and in particular, agent-based simulation modeling. So the agent is rewarded for successfully committing fraud and is punished for being caught. So, and thus the agent learns some current flaws of the system and is able to learn to design new cases, scenarios, new fraudulent strategies that probably no human already came up with. So, and the system can adapt to those strategies, can learn them, and be ahead of other, potential fraudulent people in this fight against fraud.
What about you, Lyubomyr?
Yeah, actually, in this case, we also considered to use some prepackaged solution. For example, Amazon have solution for fraud detection, but it has several pros and cons actually. And in this case, we've met the problem that actually we are inventing such unique features that actually it will not be able to any prepackaged solution to invent such a feature. For example, I don't know, like when user is in the middle of the night is trying to do some action, probably it's fraudulent because usual user will not decide to do some actions in the middle of the night and the similar features. So, but in general, out of the box solutions from industry leaders will have a pretty big influence on this business, because they have ability to analyze not only your data, because they actually are listening to data feeds from absolutely different businesses, and some patterns are general enough to actually apply them to some particular clients.
Yeah, and I would like to add also to this what Lyubomyr mentioned, that we actually worked a lot with features. We generated a lot of features, and for example, we applied also natural language processing to generate features related to communication between agents and clients. And what is interesting, it turned out that claimants that made a lot of mistakes, they were more likely to be fraudulent compared to those who did not. So it was like a very interesting feature that helped us to build this more accurate system. Yeah.
And I might be naive at the moment, but I'm a great believer in shared models for entire sectors like banking, travel insurance, health insurance, and other types of businesses that, in my opinion, all of these companies should be more interested to prevent fraud and share what they've learned individually and be able to benefit from the, let's say, common knowledge in this area. It shouldn't be like a kind of competition. It should be collaboration in this area, and using federated learning with differential privacy and other data protection techniques, it can be still done without violating data privacy or business secrets. So I think that it could be also be a great improvement in the future. But we are, of course, interested what you think, our dear audience. So we prepared a couple of questions. Are you satisfied with your current solution? What do you think about the future for the fraud detection? And who's going to win, thief or police? What do you think? You can raise your hand or you can write on our chat. So we are really curious. We spend a lot of time amongst ourselves, but we also really open to know what you think.
It will probably, Jacek, always will be the struggle between fraudulent and actually thief and police. And it's good that good guys are not fighting to each other, but will concentrate on fighting to bad guys.
That's why I believe they should collaborate, like
Yeah.
you know, like police is collaborating in different types of crimes. And I got the answer that someone also, Isabella, thank you, that she believes that police will win, of course. So very optimistic answer. Yeah, but that's really, it's got more, let's say, industrialized. It's quite similar to security violation that is becoming kind of business that hackers are paid, and I think they will also discover new ways. So it's a really interesting race on both sides, let's say. And Alina, thank you. Lawyer will win 2 times on the both sides. That's, I think so. Okay. So let's move on to the other. All right. And whoever trains the better model, thank you. Natural language processing, it's a very hot topic, and no matter if someone is data scientist, it's enough to be a user of any modern technology to be the user of natural language processing, because whatever we write on our computers, there's like text spelling and grammar checks in the background. We use translation between different languages. We use chatbots. We use search engines. We try to extract meaning and context from the text. So we use it every day as the users. But from the business perspective, it's even more important to realize that most of the business data is not in the databases, in warehouses. It's unstructured, and it's like it's being considered as some kind of unutilized diamond, let's say. So the natural language processing for business is also an opportunity to benefit from this data, at least to attempt to benefit from this data that wouldn't be accessible otherwise. Yeah, so let's talk about our case.
Yeah, so the first case is actually huge financial institution, and they are collecting huge amount of text data, and usually this text data have pretty short period of like operational time, so it's part of business processes. They are somebody's writing something, somebody's reading something, and after that sometimes those documents are used as an attachments to some reports to prove something. But after that, the value sitting in this data actually disappears from the radars of business analysts, and this is not good. And why this is happening? Because the amount of data is really huge, and you either should you should hire like special department just sitting and analyzing the data, indexing it, trying to cluster the data and do the stuff, or either you should use some superhuman capabilities, as actually modern NLP techniques can provide to us.
Okay, so I will provide more details about it.
Thank you.
Thank you. So specifically about this case study, the client had a large collection of meeting notes between their agents and prospects or current customers, but they had no idea what they're in that meeting notes. But they wanted to know basically what their customers or prospects are talking about, what they like, what are the market trends. So they wanted to enable the search, the quick search through those tags, through those meeting notes. And yeah, basically that was a problem, and they came to us with that problem, and how basically what we did, how we helped this client with. Yeah, what's important? The client insisted on out-of-the-box approach. And we were aware of some limitations of those approach, which was basically AWS Comprehend. That's why after some discussions and negotiations, we came up with a decision to conduct such experiment, which was very interesting for both sides, to conduct an experiment and to compare the solution based on out-of-the-box solution and based on our custom solution. So for our custom solution, we decided to use topic modeling and name entity recognition. So topic modeling was decided to use in order to determine the list of topics in the whole collection of meeting notes. And then after revealing the list of topics, we can see it on the next slide, by the way. So after revealing the topics within the whole collection, we can figure out the topics. It could be one or more topics in each separate document. So the next slide shows how this works. We have a collection of documents. We applied, in this particular case, we applied LDA in order to create a list of topics. And then each document was tagged with one or more topics. We also applied a name entity recognition, and it can be seen in the next slide. In order to find a word or a phrase in the text. And in our case, we found both the default entity types, such as, or generic entity types, such as location, person, geopolitical or geographical entity. And also we figured out our custom entities, such as, for example, organization, like the first you can see here, Amazon. We also worked on, we also provided a list of some products. related to that company and some financial entities. So what were the results? And then that's basically the next slide, right? First of all, before business results, I would mention the technical results. First of all, it turned out that the out-of-the-shelf solution, this AWS Comprehend-based solution, it had some limitations with both topic modeling and entity recognition. Speaking about topic modeling, once the model was trained, it was not possible to tag new and unseen documents with found topics. So only tags that were used as input to that topic modeling, they would be tagged, but any other document would be not. And that was a huge limitation because basically the client wanted to label new text on the fly as well. Our custom model based on LDA was capable of doing it. Speaking about name entity recognition, back then it wasn't possible to make custom name entity recognition in real time. However, right now it's possible. So Amazon is constantly improving the services, and right now it's possible. It's not a limitation anymore. Our custom solution was even back then it was capable of finding a word or phrase of certain type in a text. So we decided the custom solution was better. And what were the results? First of all, the client was able to analyze and assess the potential risk and opportunities for cooperation based on topics and based on entities found within those meeting notes. And it helped to overview, to envision some challenges, some risks, and also to understand the customer sentiment towards the company and towards its products.
Okay, so what were the most difficult parts of the project, the challenges that you had to address?
I will talk probably a little bit here. I cannot say that it was like the huge challenge and huge problem, but when you're starting data science project, you should always think about data sensitivity and data security, because some businesses are working with open source data, the data which is publicly available. And in this case, it's totally okay to actually ignore problems with data sensitivity. But most of our clients are huge companies that are very strict about their data security. And what does it mean for data scientists? So data scientists should be ready to work in very restricted environments, to have very limited access to training data. Also, for example, when you are considering whether use or not some third-party components or third-party services, like mentioned Amazon services, you should carefully read license agreement, because Amazon can by default use your data to train their models, as we mentioned before. So imagine like huge Amazon model sitting and learning from different clients from the same business sector. And you should figure out with security team of your client whether it's acceptable or not. And if not, you should go to Amazon and ask them to switch off this capabilities in this particular case.
And I think we addressed already these limitations of out-of-the-box solutions. Am I right?
Yes,
Yeah,
you
actually.
mentioned.
So, it reminded me a little bit about 1990s when someone said that all the software had already been written. So someone could claim that all the models were already created, but we know it's not true. Okay, so what is the future of NLP, natural language processing? What do you think, Olena?
Yeah, so the first one that I would like to mention is multilingual support. So until recently, NLP support was limited to just a few languages and mostly to English, but that's changing. We see that multilingual NLP models are being introduced by such AI leaders as Google and Facebook. We have a lot of advancement in language agnostic sentence embeddings, in multilingual embeddings, and that all works towards the ultimate multilingual NLP model's success.
And I want to mention, actually, if you talk about the future of NLP, that currently we should distinguish like NLP as a understanding of text and ability of computer to talk, to summarize text and other stuff. We should distinguish these abilities from abilities of computer to think, to literally think as we humans are doing, because there's still a huge gap between intelligence of average human and computer, because computer still needs some instructions. Computer still needs some huge amounts of data behind the technologies that are mimicking thinking process of humans. And in the future, probably we will actually be closer to the situation when we can treat this personal and business assistants based on AI technologies as real humans, and it will be closer to truth, and we will have less problems with those digital assistants, with their ability to keep the context and other problems that currently AI currently have.
Yeah, then I'm maybe a little bit more short-sighted, because as the user of let's say conversational AI, I would like it to be more context aware, and I know I'm not alone. It's like billions of people would like to have that. That the conversation with let's say Google Assistants or Siri or Alexa would last a little bit longer than one question and answer. It's getting better, but it seems to be a long way. So I know that all these companies and universities also focus on this context, but what is like natural for us humans, it's very hard for the computers, like you mentioned. It's like, but the better context would give us more impression of having the actual conversation instead of command and response like we experience today. Yeah, so not yet. So of course we are also curious what you think about it, about the NLP, about the future, about the challenges. So let's give it the voice to our audience. I'm looking at the Q&A chat, so we are really curious because we spend a lot of time, especially me and Lyubomyr, almost every week discussing this more futuristic stuff, but it's really interesting. We are living in a very interesting times. So so what do you think? I mean, what's your opinion? Maybe you have questions to our case, or because it's like maybe one small disclaimer, it's one of our cases. It's the one that we picked for today, but of course we've got more.
And actually, if audience is not asking us, we can try to ask audience.
Yeah, because this, like for instance, this fake news. I think it's very interesting topic, because we know that there were many attempts to detect fake news, and it appeared that there were hundreds of people employed behind the engine, so-called. It was probably Facebook like a few years ago. So even small, we are very sensitive to the language, and it's hard to teach the sensitivity, say, the computers. Like it's our primary way of communicating with each other, and for computers it's not their primary way. They use binary systems and electrical signals, so it's really far away from their nature, let's say, compared to the humans. So yeah, but what I really like this growth of this multilingual NLP, because even a few years ago it seemed that we are, let's say, condemned like to few main languages, and like 70-80% of humanity is left behind. But yeah, it's really getting better. So even the latest engine from Google is really focused on any language, in fact, that can be represented as text. So it's really moving towards general.
Yeah, it's very important in terms of AI in general, because moving to this point when models of translation model and actually text summarization model and other models related to languages become a language agnostic, it moves us closer to real AI, because computers are actually getting from the text like abstract entities. So they understand that this is the table, and actually it doesn't matter in which language we are trying to say table, which is important.
We've got the questions from the audience. Thank you very much. What blockers do you see for AI at present? What are the most, say, blocking issues? That's what I understand.
Jacek, you probably is specialist on this topic. I'm not.
Yeah, maybe I will start with my understanding, and Jacek will proceed. So first of all, what are the blockers for using AI like at present? A lot of people are not confident in using AI because they are not sure how the model will behave in the future. So the data could change over time, and this can cause the model to underperform compared to when it was trained. But this is already not a problem, and we can deal with this stuff as well, because we can monitor constantly the model that was trained before, and we can figure out some criteria when the model should be retrained on the new collected data, and improve its accuracy. Another problem is actually the data, but not the all the data that is around us, but actually labeled data for the model. A lot of models are still based on labeled data, and that is time consuming and labor consuming. So still it takes a lot of time in order to prepare the data, and then to build the model, and we are not sure about how stable the solution would be. So that are the main challenges that I see right now for using the AI like each and everywhere.
Yeah, and you stole the best parts from me, so I would try to keep up. I think that there's still some kind of, let's say, challenge, maybe not a problem with the generalization of the models, but it's getting better, like you said. And I think the model tuning used to be more like black box magic, dark magic almost. Now it's also made more, let's say, semi-automatic and simpler, at least from the outside a little bit. But I think that the main problem, and I think that was the focus of many discussions that I attended, is explainability. And it's still lagging behind, and we shouldn't have to choose between explainability and accuracy, because like you mentioned, we sometimes use, let's say, less advanced methods to be more predictable, but it's at the expense of the accuracy. very often. So I think that should be and also this requirement is not stated at the beginning of the projects, which might seem very unintuitive, counterintuitive, but that's the reality. That it's sometimes for the business users, especially, it's like it's like in the software. So show me this line of code that breaks. It's not so. It's much more difficult, like billion times difficult to point out. Like I don't know, node in the network or something. So yeah, but like we discussed before, like you said, it's getting better. Like all these aspects are getting better, but it's still a lot of work to do. And I think that is why these projects are getting more and more successful. Is maybe I will share also with the audience and with you, is that people learned what to expect from AI for business. It's like the expectations got real. Not they are still ambitious, they are still require a lot of competence and a lot of experience and technology knowledge, business knowledge. It's like not going anywhere. It's like key requirement, but they learned what they can really expect and what they can benefit from. So it's also a great success of collaboration between data science teams and business, that the both sides learned what to expect from each other. I think that's the reason why, one of the reasons why the probability of successful AI projects is increasing. Finally, I would say that that's also very important. It's more like maybe human aspect than technological one, but it's also important that we know very well at Avenga what we can deliver and what cannot be delivered with the current set of technologies or with the data available. We know that, so that's like the first part of our conversations. Like we want to deliver something useful, something that will matter, something that will influence the business, not chasing the dreams. So that's what we showed today. I hope that the audience would agree that we showed the real life cases that are true, that are not something like hello world in AI, but it's like this is the real life. That this is what we at least touched today. Another question: fraud detection solutions for unknown languages that are pre-translated into English. Is there any way to deal with such AI unknown languages to have a semi-good quality solution? Is it worth trying, or is it just wasting of money for now in the year of 2021? So it's probably to Olena, I think.
I see a combination of fraud detection and NLP in this question. So let us first figure out for ourselves, what do you think about fraud detection solutions for unknown languages? What does it mean? What do you think, Jacek, Lyubomyr? How it could happen, like fraud detection for unknown languages?
No, I think that Igor is trying to ask us whether solution, when we will translate, for example, I don't know, German to English and then feed this English text to some out of the box solution from Amazon, for example, for fraud detection, will it work, or we shouldn't try to do this?
I think I am like finding the problems, and one of the problems that I'm loudly thinking of is that the frauds are very often detected when someone makes a tiny mistakes, like Olena mentioned, like one letter is wrong. It's like very subtle errors in the using of the particular language. If it was translated, I think that we would miss many of these details. That would be like Polish, and that would be lost in translation. I mean, pun intended, lost in translation. That would be my opinion, that we would lose this key tiny bit of information that would be decisive for the algorithm to detect the fraud. That would be my concern. What do you think? Am I exaggerating?
Yeah, actually, if I understood the question right, yeah, and we are trying to translate some unknown languages to English to fit the English to some black box to understand whether it's fraud or not. As Jacek said, it will wipe out like half of the kind of sentiment that is helping this black box to understand whether people is trying to do the fraud or not. So we should at least be very careful doing this.
On the positive sides, the latest, let's say, models that they are publishing online, they are much better in even working with truly unknown languages that they were never trained before. They even operate on the bytes, not on the words. So I think that the future generation of this NLP engines will make it not necessary to translate in the first place. So I think that's going to be the solution, in my opinion. If I were to bet on something, I would bet on these new engines that will be very much, let's say, language neutral.
Yeah, and we do have some enhancement in zero-shot learning, which is actually such a problem setup in which we are trying to classify something that were not in the training data set. So, for example, this unknown language were not in the training data set. We never seen that before, but nevertheless, it could be classified as fraudulent or not fraudulent. For example, if we are talking about some, news or something like that, using this zero-shot learning techniques.
Yeah, and I think that what we are also tracking and going to track in the future for detection attempts or projects is this behavioral patterns, and they are not so much language dependent. It's more like activities on the user interface, for instance, some kind of the speed of these activities, the timing, and like other parameters that are not related so much to the language. So it's not so bad, even with the current state of art, let's say. It's doable, I would say. Oh, he wrote, okay, thanks, and you're welcome. It's like all of these topics that are huge, and this is really hard to follow. I think, yeah. So that's why we have an entire team dedicated with Olena as the head of this team. So we try to catch up with this latest and greatest, sometimes greatest.
Yeah, Jacek, we have a question about cybersecurity in context of AI. Did we have any security incidents related to this project?
So I will probably start. We already mentioned, right, some issues with that could probably happen with that second NLP case, the case that dealt with really sensitive data. And as we started our this exercise of comparing the out-of-the-box solution with our custom solution, it turned out that the Amazon could use customers' data for future model trainings and for like storing the data somewhere. So it was basically figured out during this project, and all we needed just to let know the AWS that we do not like the customer's data to be stored anywhere and used anywhere later. So also speaking about other projects that were not mentioned about today, we had customers that just do not want to share their data with us. So they are so sensitive that we can't even see them. So for those clients, we are working on like using such techniques as federated learning in order to prepare some scripts and to just share the scripts with them based on metadata of that are describing their data. And then those scripts for experiments will be conducted on their site, on their like on-premise or on their cloud subscription. Yeah, and that's also the answer how to deal with super sensitive data.
And yeah, that's like also deal with the myth that the model, let's say, is like anonymization technique. It is not. So it's one of the common myths that the model is let's say safe enough to be shared. No, it's not true. Like there are many techniques that people can infer a lot of about the data from the model. So this is also this kind of relation between cybersecurity and AI, that the models themselves are also revealing more than people think. That's one of the misconceptions. Yeah, so that's what I said. Like the model is not anonymization technique. It's kind of aggregation, but it's not anonymization.
Yeah, and I recall another project when the client asked us to collect all possible data related to health from people from United States, and the idea was to show that we can collect different data sources from different places, and then we can combine them in order to identify the real person. So even those data sets that we collected, a lot of them were anonymized, but after collecting enough quantity of data sets, we can apply some AI algorithms and basically do some identification of people. However, it turned out that such activity were not legal. So we figured out during this, this project that it wasn't allowed. So right now we are aware of it, and we know other such issues that we can encounter with. So we can think about sensitivity of data and data protection all the time.
And let's not forget about the new regulations in European Union that are specifically addressed at AI. So it's getting like harder and harder to comply, and it requires a deep knowledge how to deal with these regulations, how to practically interpret those regulations, but they are not going to get any easier. That would be my prediction, that I wouldn't expect that they will get easier, because there's a huge value of data, and there's a lot of need from the human rights perspective for the privacy of people. And another question, what do we offer, from Alina, thank you. What do we offer for fintech in terms of AI?
What kind of offerings can we provide for such customers? So we do have a list of such offerings. I would like to mention some of them. For example, I would like to mention customer analytics, we started to say about customer segmentation, and we started to say about sentiment analysis, but we can also do customer segmentation in order to understand the groups of customers and how to contact them, what kind of personalized messages we can contact them with. And we can do like a lot of other stuff in terms of customer analytics, such as churn prediction, some propensity score of the client to buy another product, some recommendation systems for them, dealing with some recommendations on what should we recommend to that client to buy next, for example. And that's only in terms of customer analytics. But we also mentioned fraud detection as the first our case study. We also have AI-powered data engineering. So so each company right now in this phase of digitalization deals with a lot of data, like collecting tons of data. But a lot of them have issues with quality of data, with some data maintenance, with some data protection, and maybe they want to enrich the data for future AI analysis. So we have such offering referred to AI-powered data engineering, so that we can help in creation clean data with the help of AI, with the help of some text and recommendations on data entries, and We can match the data from different data sources even without having IDs and so on. So that's in terms of AI-powered data engineering. We can do also NLP and dealing with large collection of documents. Something similar to what we have already mentioned about dealing with texts. We also deal with computer vision. We can do optical character recognition, for example, for revealing text out of images, out of some files that were not converted to text. And predictive analytics. So we can talk about some financial planning or resource planning in terms of how many resources we will need to deal with all of our clients, or how many investment should we apply, and so on. So if the client already have some AI solutions, we can provide some assessments on the accuracy of the model, on the performance of the model, etc. We can also apply some ML ops, machine learning operations, based on orchestrating that model, monitoring the the performance of that model, and so on. So the list go on. So I can talk about it forever. But Jacek, Lyubomyr, maybe you will.
I'm also working with the, let's say, multiple clients with totally different industries, and at some level, they do. I mean, from the domain, technology domain perspective, they do very similar things because they are very heavily IT and data-driven companies. So like what you mentioned, what you described is like almost everything. Like if someone would ask us about like insurance company, we would probably use maybe a little bit different wording, but it's again like all the companies are becoming data-driven companies, and we can help in any step, because sometimes it's a question of even the data structures, data sources of very early stages, about designing the data landscape, data ecosystem, to the very advanced projects in AI. So we can help at any step along this way. So that I would answer to any industry.
Yeah, I would add probably time series analytics, because prediction is part of this, but there are other like things that you can do with time series, like multi-dimensional time series analytics and single dimension time series analytics. So we are doing this as well.
And what I would also mention additionally is that KYC, know your customer, which is very important in the entire financial sector, and in fintechs in particular, or maybe a special in fintech, is getting more and more difficult, and more advanced techniques have to be used to be able to do this, because of the growing privacy regulations and penalties and techniques. So they have to, let's say, work on the scraps of the data to be still within the regulatory space and still be able to personalize the offer. That what we mentioned before. So also this aspect is using AI more and more, because it's getting more difficult to gather data about the customers and their behaviors. I think we answered the question. Oh, thank you. Thank you very much for your question.
We have no questions, so I can summarize a little bit one important thing that I'm constantly saying about data science, that data science is not like solving some problems, but mostly data science is really powerful thing, because it transforms your business. And this case with microinsurance company is very good illustration, because guys started from like personal belongings inventory, and then data science helped them to take this step forward and transform to microinsurance company, because they analyzed their clients, they understood their behavior, they They actually were able to build the future business model, and they did this step. And after that, running microinsurance companies, they continue to use data science to get additional value from their data. They use data science to fight with fraudulent attacks and other stuff. And after that, they made step forward again. And now, as I know, they are not running like a microinsurance company, but they are selling this platform as a service to big insurance companies. So this platform probably is working in several huge insurance companies as a part of their services.
Yeah, I would call it true digital transformation.
Yeah.
With emphasis on true, because this term is overused nowadays, but this is the great example, and thank you for sharing. So I think, and I'm looking at our Q&A chat, so thank you very much. I don't know if you recognize this picture on the right. It's kind of inappropriate usage of AI and a Space Odyssey 2001. But we want to end up with the big thank you for your participations, for very interesting questions. I hope you enjoyed it as much as we did. So thank you very much.
Thank you.
Thank you.